Welcome to the Defense and Aerospace Report. I'm Vago Muradian at the Association of the U.S. Army's annual conference and trade show in Washington, D.C. And we have with us Mark Signorelli, who is the Vice President and General Manager for Combat Vehicles at BAE Systems. Sir, thanks for joining us.
I'm very glad to be here. It's another great show. We're 2 hours into it, and I'm already exhausted.
That's always a good sign, actually. The more tired you are at the beginning, the better you know it's going. Mark, bring us up to speed. I mean, this is the AMPV. Obviously, it was a contested program. You guys ended up winning in part because the other competitor didn't want to bid on it. You guys have invested considerable amount of money, up to $200 million, to develop the technologies, to adapt, if you will, the Bradley to replace the M113, the legendary vehicle, the most numerous, prolific armored vehicle in the Army's inventory. Tell us a little bit, bring us up to speed on the program and how you're handling the challenge of doing development, because this is a prototype, and production at the same time.
Sure. Well, program is moving along very well. We had a critical design review this last summer. And following that, we've moved into production of the 29 vehicles in EMD. We have 8 of those vehicles on the weld line right now and 1 in assembly. And we'll deliver that first vehicle in December of this year. So making great progress there. The program is delivering on what it said it was going to do. Taking the base Bradley platform, improving the survivability, and configuring the back end for a number of variants. This one you see here at the show is configured as a medical evacuation vehicle, but we also are working the mortar vehicle, medical treatment, a general purpose vehicle, and then the mission command vehicle, all of those together. We are delivering what the Army asked us to here. A much larger volume, a more survivable vehicle, and commonality across the Armored Brigade combat team. So,
let me take you to the question, though, of the concurrency issue, right? I mean, when folks looked at the Joint Strike Fighter program, one of the big lessons learned, they say, is, look, don't start building prototypes, and you're not finished with development before you start production. How are you avoiding or learning? How are you avoiding some of the same mistakes on this program?
Yeah, so I think we're trying to avoid as much as we can, but we're also managing some concurrency. Anytime that you've got a vehicle or a program that has got a set and somewhat compressed schedule, you're going to have concurrency. And what we're trying to do is make sure that as we develop or finish the design, we've got a flexible process to cut that into the manufacturing floor. And to sort of bundle those changes so that you can make sort of, even within the prototypes, block modifications. And we think that's working. It's never easy. If it was easy, everybody would do it. But we think we're managing that pretty well. So,
how are you? Everybody is looking at retooling all of their manufacturing processes, trying to take as much touch labor out of it, to try to be as thoughtful as you can with the design, to try to take as much cost, not only front-end cost, but also through life service and support costs out of it. How did you fold some of those lessons into this vehicle in how you're building it, but also how the vehicle will be supported once it's in the field?
Yeah, so this vehicle really leverages the entirety of the Armored Brigade combat team. Uses components common to Bradley, and the M109 A7 PIM program that allow us to get a level of commonality unprecedented in a formation before. So we've done that. We've also leveraged manufacturing technology advances. Many of those were developed in conjunction with ARL and their ManTech programs that allow us to manage.
That's the Army Research Lab.
That's correct. That allows us to make the vehicle more survivable, but also because we've done those development efforts in-house on our manufacturing line, they translate almost directly into the production processes that we're using here.
Let's also look at the vehicle that we've got behind you. Obviously, this is an AMPV, and we know what it is, but that has bits and pieces from different vehicles on it. Tell us a little bit about what we're looking at there and why you guys built that vehicle.
So last year, we came to AUSA and we showed Army leadership a virtual concept of what a fully modernized Bradley could be. And so what we told them is, we're going to take your feedback from this virtual concept We'll be back next year with the vehicle. And so what we have here is what we're calling Next Generation Bradley. We've taken lessons learned survivability from AMPV and actually have improved on that. So a next generation of survivability improvements. And we've improved the mobility. We use the same engine that's in the AMPV and Bradley ECP2 and PIM, but we've mated that to a new high efficiency transmission that effectively gives us 200 additional horsepower out of the same engine. We've improved the underbelly survivability, the blast, and we reconfigured the back of the vehicle so that we've taken all the energetics, fuel, ammunition, tows, out of the interior of the vehicle, raised the roof height so that we can fit those 95th percentile soldiers in there. This is the first step in what we expect will be a multi-year program, because what we really want to do here is demonstrate that we can rapidly integrate technology as long as we have the vehicle infrastructure right. And so we intend to show the Army a series of upgrades of what a next generation Bradley or next generation combat vehicle might do for them.
And let me ask you about the troop compartment in the back. How is it different from its predecessors? Why are you guys so proud of the design on that?
Well, one of the biggest lessons we learned in Iraq and Afghanistan was underbelly blast. And in the Bradley, we have an issue with fuel in the troop compartment. So we've taken all that fuel out. Again, a common solution with AMPV. We now have external fuel tanks. We've taken the tows and AT4s out of the crew compartment where they were stowed under the seats before. We put them externally where they're accessible but more survivable. And as we've raised the roof line, we've done two things. We've improved the survivability from blast. We've also accommodated those taller soldiers, something you and I probably don't have to worry about very much, but most of our soldiers do. So we've made it more survivable and more ergonomically configured for soldiers.
And let me ask you one last question. How much are these two programs, what is their market value to the company over the next couple of years? How much money is tied up between Bradley upgrades and the AMPV program for you guys?
In terms of Army budget, AMPV could be a $10 billion program for the Army, given that we build the number of vehicles that they've programmed. Bradley upgrades, I think that's going to depend on what the Army decides the path forward is, but could certainly be a program on the same scale as AMPV.
The last thing I want to ask you is, do you see an international market for AMPV? I mean, that is, at this point it is a U.S. program, but the M113 is in service around the world as well. Do you see an international market for the AMPV upgrade?
I think there will be. I think this is one where international customers are going to look to see what it does for the Army, the U.S. Army, as they implement it. And we will see, I think, an evolution of this program towards international customers. Very much in Denmark, they procured a vehicle very similar to this. They were looking for a European supplier, but I think we'll see a market emerge over time.
Mark, thanks very much and best of luck with the programs.
Great. Thanks very much and enjoy the show.